Page 12, last page of differentiation rules. Number 6, consider the function 2x cubed minus x. Complete the following table by indicating whether f of x, f dashed of x, f double dashed x are positive, negative, or 0 at the given values of x. Okay, so they already did the first one here. They said that at x equals 0, or x equals negative 1, f of negative 1, which would be 2 times negative 1 cubed minus negative 1, which would be equal to negative 2 minus a minus 1, which would be plus 1 equals negative 1. That would be negative. Okay, so f of negative 1 would be negative. What about f of 0? F of 0 would be equal to 2 times 0 minus 0, which would just be equal to 0, so that would be 0. F of positive 1 would equal to 2 times 1 minus 1, which is equal to 2 minus 1 equals 1. That's positive. F dashed of x. Okay, so let's find f dashed of x first. We don't know that. F dashed of x would be the derivative of 2x cubed minus x, which would be 6x squared minus 1. And what if we put negative 1 in there? Then we would have 6 times negative 1 squared minus 1, which would be equal to 6 minus 1 is 5, which was positive 5. So that would be positive. What if we put in 0? If we put in 0, it would be 6 times 0 minus 1, which would be 0 minus 1, which would be negative. What if we put in positive 1? If we put in positive 1, it would be 6 minus 1 is 5, positive 5. Would be f double to take the derivative 12x. Okay, and then if you put in negative 1 into 12x, it would be 0 into 12x, you get 0. And if you put 1 into 12x, you would get positive 12. So it would be negative, 0, and positive. Moving on to 7. Given that the function is 2/3 sine of 3x, show that the third derivative of sine of 3x, and then substituting x equals 2 pi over 9, equals 9. Number 7. So if I'm going to take the derivative of this, the first derivative, I'm going to get 2/3, oops, put the equal sign there, and then I'm going to find the derivative of sine of something, which is cosine of something. I leave the inside the same. I take the chain rule, and I take the derivative of 3x, I get 3. So that would be equal to 2 cosine 3x if I multiply the 3 times the 2/3. If I take the second derivative of that, then I'm going to take the derivative of cosine, which gives me negative sine of something, and then I take the 3 out, so I'm going to get negative sine 3x, and then the chain rule, the 3 comes out. So then I end up with negative 6 sine 3x. Okay, and then the third derivative is going to be negative 6 cosine 3x multiplied times the chain rule. So it would be 3 there. So it would be negative 18 cosine 3x. Okay. And then it says if I put in 2/9 pi in here, so if I say x equals 2/9 pi, then I'm going to get 9. Let's see how that works. So I'll put negative 18 cosine, and we'll have 2/9 pi times 3. So it'll be 3 times 2/9 pi, and we'll see what that equals. It's negative 18 cosine, and it looks like 6/9 pi would be multiplied out. 6/9 pi is the same thing as 2/3 pi, so let's rewrite that. Negative 18 cosine 2/3 pi. And 2/3 pi is 120 degrees. The cosine of 120 degrees is equal to a half. So, negative 18 times 1/2 equals negative 9. And I did something wrong here. Let's see if I can find where the negative sign was lost or came in. So the first derivative I took was cosine, positive cosine. That's fine. The second derivative I took, the derivative of cosine is negative sine, so I got negative sine here. That's okay. And then the third derivative I took, I still had the negative, so it's negative cosine. It would be the derivative of negative sine. So should be negative, negative. Oh, I see. The cosine of 120 degrees is negative 1/2. It's negative 1/2. So negative 1/2 times negative 18 would give me positive 9. Okay, so that's fine. Positive 9. So I got what I was supposed to get. Okay? All right, moving on to number 8. Show that the function blah, 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 or suppose that the function blah, blah equals blah, blah, blah. Show that the first derivative equals this. So we're going to take the first derivative. We're not even going to look at the answer yet. And we're going to get, okay, the first term, we're going to get 2 times 3 sine squared of x. Why? Because first we see that there's kind of the power rule going here. We got something cubed. So the derivative of something cubed is 3 times the something squared. And then we don't even have to do the chain rule because inside there's just oh, we do have to take the chain rule. The chain rule of sine squared, the sine part of it is going to be cosine. So we'll have cosine of x as a result of the chain rule. And then we have 3 times cosine x. That's a pretty easy derivative right there. Okay? And then, let's see, can we... Oh, I think they want us to factor out a cosine because there's a cosine in both, right? So if we factor out the cosine, then we'll have 6 cosine, I'm sorry, not 6 cosine, we'll have cosine x factored out, and then here we'll have, maybe we'll factor out a negative 3 too. We'll factor out negative 3, and so then we'll have negative 2 sine squared x, and then this will just be plus 1. So now we have negative 3 cosine times 1 minus 2 sine squared x. And remember that 1 minus 2 sine squared x is an identity that is equal to cosine 2x. So cosine x, and then this is replaced by cosine 2x. This goes back to last semester. Okay, so cosine 2x is equal to 1 minus 2 sine squared x, and so that's how we replace that. Okay, now we find the double dashed of f, which is, we're just going to take one more time, we're going to take the derivative of this. So that's going to give us, let's see, we're going to have to use the product rule here. We're going to have, if we call negative 3 cosine x like u, then v, so like we'll say that this is u, and we'll say that this is v. So first we'll just take u, and we'll write it down, which is that. And then we'll take v dashed, which is cosine 2x, would be negative sine of 2x times the chain rule, so multiply by 2 after that. Okay? And then we add that to u dashed, which would be negative 3 cosine x. The derivative of that would be negative 3 times negative sine x, which would be positive 3 sine x. That's v dashed. And then we multiply it times, or that's u dashed, and then we multiply it times v, which is cosine 2x. Okay, so the result is we have negative, we have 2 negatives here, so this turns into a positive. So simplifying, we'll have 6 sine 2x cosine x plus 3 sine x times cosine 2x. Okay? Alright, number 9. Find the second derivative given that the function is x log x. Okay? So the first derivative of that would be equal to, and so we're going to say that x is, so if we use the product rule here, we make x into u and log x into v, then basically it's x derivative of log x, which would be 1 over x, plus derivative of u, which would be 1 times log of x. So that's the first derivative. Now we find the second derivative. So we take the derivative one more time. By the way, if you multiply that out, it's 1 plus log of x, right? So if you take the second derivative of that, the derivative of 1 is 0, and the derivative of log x is 1 over x, and you basically end up with 1 over x. All right. Now for c, the first derivative, you are going to recognize this as a power. So you're going to do the power rule. You put 2 in the front, and you put log x in the middle, and then you take that to the power of 1. And then you take the derivative of what's inside as part of the chain rule. So you end up with 2 log of x divided by x. And then when you take the second derivative, you are going to you could do this with the product rule or the quotient rule. Let's do it with the product rule. It's easier. So we have 2x, let's think of this as 2x to the negative 1 times the log of x. And then, so let's first say, let's say that u is x to the negative 1. So first we just rewrite x u, and then we multiply that times v dash, which would be log x, and then we add that to now we're going to take the derivative of 2x to the negative 1, so that would be negative 1x to the negative 2, and then we just multiply that times log x. So that's equal to 2x to the negative 2 minus 2x to the negative 2 log x. 11. So now we have an exponential function, and it wants us to take the first and the second derivative and then show that this equation is satisfied. This is called a differential equation, which you're going to use maybe in your future math career. Very cool equations which have derivatives and the function itself in them. So let's first take the first derivative of this, and we'll end up with, let's see, 2 times e to the 3x. The derivative of e to the 3x is e to the 3x itself, times the chain rule of what's in the exponent. Chain rule, the derivative of 3x is 3. And then do the same thing with this. So derivative of e to the 4x is e to the 4x itself, and then multiply times 4, which is the derivative of 4x. So that is equal to 6e to the 3x plus 20e to the 4x. Now I'm going to find the second derivative. The second derivative would be 18e to the 3x plus 80e to the 4x. I just took the chain rule and I multiplied it already times the coefficient. Now I'm going to see if this is really true. So if I put the second derivative here, it would be 18e to the 3x plus 80e to the 4x. And then I'm going to take minus 7 times the first derivative, which would be 6e to the 3x plus 20e to the 4x. And then I add 12. I add 12 of the original function, which would be 12 times 2e to the 3x plus 5e to the 4x. And then that's supposed to all cancel out with each other. Let's see if that's really true. So we have 18e to the 3x plus 80e to the 4x. We have minus 42e to the 3x minus 140 e to the 4x plus 24e to the 3x plus 60e to the 4x. Now let's see if all this cancels out. So I'm going to color the e to the 3x terms orange. And I'm going to color the e to the 4x terms pink. And we'll see how it goes. Let's see, e to the 3x's. We have 18 minus 42 plus 24. Yeah, 24 plus 18 is 42. 42 minus 42 is 0. So yeah, the orange terms all cancel out. The pink terms, 80 minus 140 plus 60. Yeah, 80 plus 60 is 140. 140 minus 140 is 0. So yeah, all those terms cancel out magically. Cool. And that's exactly what a differential equation is. It's like usually the solution to a differential equation is going to be the exponential function, because exponential function is the only function where the derivative is the function itself times a constant factor. So those are the types of functions which can satisfy complicated equations like this, which have the derivative, second derivative of the function plus the function itself in it. Okay. This last one. So if y equals sine x, show that the fourth derivative of sine x is equal to the function itself. So the first derivative of sine x is cosine x, of course. No, you don't have to do the chain rule, because inside you just have the x itself. Then you take the second derivative and you get negative sine of x. You take the third derivative, and I don't know if this is correct notation, but and then I'm going to take the fourth derivative. Probably is not correct notation. So the fourth derivative, the derivative of cosine, remember, is negative sine x. So there you go. And so, yeah, the fourth derivative is equal to the original function. That is true. Yes. Okay. And that's it.